Hi, this is Team 5. We are the server team, and the main contributors for this team were Arjun Pasi, Swana, and Nathaniel Hughes. We'll be going over the software structure and design and the test cases we wrote to test our software and other. Hi, everyone. This is Arjun Pasi from the server team, Team 5. This is a team demo of the software that's running on our servers. So just to give you a quick demo of the structure, we have pretty much divided into two pieces. That is controllers and repositories. So a controller is pretty much an object that will handle the HTTP requests coming into our servers. So whether it be a GET request, a POST request, a PATCH request, a DELETE request, everything first comes to the controller and then it goes to the repositories. Repositories are doing the extra logic of where does this request need to go? Does it need to go to persistent storage? Does it need to go to decision making? Does it need to go to the device team? Where does it have to go? So, for instance, we have multiple controllers depending on whether the request is coming from the app or from the decision team or from the the house team or the storage team. So um, this is an example of an app controller. So an app, for instance, an app would like to post a device token on the server so that the app would be notified of any changes in the devices or any other notifications. So this is one of the so app would do an HTTP post request on the server by giving this route, and the request will come out to this function, and we have a user repository defined that will do the logic of communicating with the Amazon Web Services, creating a platform application. Uh, so this is the function where it's actually doing it in the user repository. It's creating a platform applications. It's getting the necessary ARNs that are required, and then it's posting those ARNs on the persistent storage. So whenever the user needs to be notified, all it has to do is all we have to do is grab the information from persistent storage and pass that ARN in our publish notification function that is just a simple call on Amazon Web Services that does the magic for us. So to give you a quick a video demo of the notifications working, we have a video from the app team that is essentially doing the same thing. So he is first registering a user, and he will then post a device token to the server, and from Postman he's gonna send a notification. So we have given them an API call that they can do so to get notifications. This is something for testing purposes only, um, to demonstrate that we have integrated well with the app team. So he just got a device token, and he posted it. So what he's going to do is he's going to provide his credentials and send a message, and he will receive that message on his Android device. You can see he received the new devices are available message on his Android device. We have a same sort of functionality on the iOS device. So just to give you a demo on that. So there's an iOS app opening, and he's essentially doing the oops. So he's essentially doing the same thing where he is sending a request from Postman, and his iOS device gets that notification. So he can see he just did a request from Postman, and he got new devices are available on his iOS device. Uh, the logic is pretty much the same. You just need an endpoint and a platform application ARN, and you're set to post notifications on multiple devices. So that'll be it. Thank you.
Hello everyone. Our program is robust in terms of integration with the server for other teams. Here I will show you our external tests that are being passed. In these tests, we constantly query other teams such as persistent storage, house, which will be running locally, decision making for different information. We are also using the device API provided by the device team in our code for different purposes. The test will act as a user sending commands to the server, and the server will react accordingly. So before I run these tests, I need to run the house locally on my machine. This is similar to running the house via a SIM harness app. Once the house is up, I'll run all my tests. So while the tests are running, I'll show you a couple of examples of how our system is integrated. So when the user wants to update their location, they would basically go to our URI and do this routing of API app user update position. Once that happens, what happens is it will come to our method in this, and then it would go to on update position function. In this function, we get all the information that was sent by the user, and we will forward that information to the decision making team, which has their own URL under dm_URL. So once the decision making receives this information properly, they will return us true, and we will return that true back to the user. So once the user gets it true, in our unit testing, we make sure that the testing receives true back. So another example is when posting a house, we first request our server to post a house similar to what the user would do via app, and then in our code we would basically post that information to the person storage. And in the same test, what we do is we try to get that house using our own URI. And if we are able to retrieve that house from the persistent storage, it means that it is able to successfully talk to persistent storage, save some information there, and retrieve back successfully. In these tests, we are also sending information to the house and receiving information back from the house, which is running locally in the machine. So as you can see on the left, all of our tests passed without any error. So this shows us that our software, that our program is properly integrated with all the teams.
In the declaration of this dictionary, we're using the full ID, which is defined in their API, as well as a device type, which is also defined in their API. The full ID is a combination of a house ID, room ID, and device ID, and it's a unique identifier for a device. The device type is simply a representation of a physical device, has all the properties you'd expect a physical device to have. And this dictionary is really the backbone of the app cache. It allows for quick access from the app and allows the app to query by a unique device identification. I want to mention that the app cache is it's not thread safe. Due to our limited time constraints, we never implemented multi-threading as a support for multiple clients. So designing the app cache to be thread safe was never a priority. However, it is something we would have liked to get done.